The CTO's role is to use technology to advance a business, and that sounds really generic, but it means you're not just, let's say, the head of IT, right? The head of IT is using computers as a tool internally, and making sure that people's software updates are refreshed and getting the MacBooks ordered on time and so on. That's a very important job. But the CTO's job is, okay, look at where technology is today, where it's going to be tomorrow, figure out how we can adopt it, figure out like what our architecture looks like, and use technology as the guiding principle of the business. And it's a particularly important role in a technology company because in many ways it defines kind of the future of the business. And it has it intersects with lots of other things. It intersects with business development, and it certainly intersects with comms, and you do a lot of public speaking and a lot of recruiting and so on and so forth. You're basically like the senior most engineer often at a company in a sense.
Got it. And so if someone is entry level engineer and is thinking about getting up to this role, what's the typical path to get to that level, and what kind of things do you have to do and learn along the way?
Well, there's two ways to do it. One is to just start your own company and call yourself CTO. That's what I did starting out, right? And then you have to grow into the role and build that into multi-100 person company. We sold that for a few $100 million recently. So that was kind of okay. You take the title, just like you start a company, call yourself CEO, and see if you can fill those shoes that you just made for yourself. And the second way is to work your way up within a large company, also totally legitimate, kind of thing. If you look at Satya Nadella or Sundar Pichai, they started as just engineers within Microsoft and Google respectively, and worked their way all the way up to CEO. So it's sort of similar, to work your way up to CTO.
Yeah.
So as a CTO, and I'm actually also CTO of Career Karma. How do you stay up to date with all the technologies? Because there's so many new trends. There's serverless. There's React, the completely new way to write front end, and just kind of how do you stay up to date with all the technologies and decide what's the right fit for your company?
Well, that's a really good question. I think so first is to be a good CTO, you actually need to enjoy technology as a hobby. When somebody else might go to the club, you're like, hey, let me stay home and mess around with this new, piece of software or this new 3D printer or something like that.
Mm-hmm.
And that can't feel like a job. It's actually just something you want to do, right?
Yeah.
So that's kind of one aspect of it where you really need to live and breathe it 24/7. And then kind of another aspect of it is sort of the taste in when to know, hey, this is bleeding edge and it's cool to know about, versus, okay, this is ready to start rolling in to our products. It's actually firm enough to base something on. Steve Jobs actually had a good one-liner on this where he said that Apple invests in technologies that are in their spring, right? Not their infancy, but in their spring, right? So usually that means somebody else has taken some risk on the technology, and now it's functional enough that you're not the very first company to ever have tried to make money with it or to do something real with it. And I think that's a good rule of thumb. You wait for somebody else to have taken the hit. So let me give you an example. With Rust, I'm sure there's been a lot of good programs written in Rust, but within the blockchain community, Parity, one of the major Ethereum clients, was written in Rust. And while Parity has had some bugs or what have you, overall, Rust has proven itself, at least within the blockchain community, because everyone's seen, okay, you built a massive project, a blockchain, which is a really hard thing to build. It's like a database and a protocol, and it's in this case also got a quasi little compiler in the sense of something that takes Solidity and turns into something. And that's complicated to build, and you can build that all in Rust. Okay, someone else is taking the hit on Rust. You can do something real in it, right? And I think the third thing is to make sure that you're not just not too early and not too late, but that you're always thinking about how each of these pieces fit together, right? And it's very easy to just have shiny object syndrome where, oh, you see something in Hacker News, let's put that into production tomorrow, right? That's like, beginner CTO kind of thing, right? Where it's tempting to do that. Oh, this thing, all the engineers are talking about it and so on. But usually what you want to do is bookmark that and then set a calendar event for yourself. 6 months in, 12 months in, 18 months in, when people are not talking about it, you go and you assess the state of it. and then you say, hey, is this trending up? Are there things happening that are kind of quieter but aren't in the news per se? So I set my own kind of cadence so that I'm checking in on something as opposed to it checking in on me. And often, like by playing offense rather than defense, then you can really monitor technologies and kind of control what things you introduce at what time.
Got it. And so, given that you're in this leadership role and you've done it as a founder and you're doing it at a larger organization, something that we haven't really unpacked on the podcast is technical debt. So, can you talk a little bit about technical debt and what committing to the right code base means and things like that?
Sure. So, the concept of technical debt, it's a good phrase because basically what it means is that you are getting something done today that you're going to have to pay for tomorrow. And often, what that means is, okay, we need to ship the product tomorrow or later this week. Therefore, we're going to copy paste this bit of code because it's too much work to factor it out into a proper library and make it an API call. We're just going to copy paste it, and we know that's introducing so-called technical debt. We're going to go back in the future and have to do more work to clean it up, but it's expedient. It will get us our launch. It'll be functional. Customers will be fine with it, et cetera. And there's many, many different forms of technical debt. That's one of them, copy paste. But there's others like, we're going to use this old MySQL database rather than migrating to Postgres, or we're going to run analytics on the prod site rather than moving to Redshift, or whatever. A lot of different ways that you can do something suboptimal that's expedient that will cost you in some ways later. Right?
Got it.
Yeah.
And
so how do you manage as a CTO? How do you manage technical debt? And like, what type of principles do you try to follow to make sure your teams and people that report to you follow in regard to technical debt?
Well, one thing is it's always tempting to just stop future work and pay off technical debt. And that almost never is the right answer because maybe once in a while, but the big bang switchover, the big bang cleanup, the problem with that is it's usually not something that's visible to customers, number one. And number two, it's always more complicated than you think, right? There's a reason that those old hacks happen the way they did. So I'm a big fan of like incremental pay downs on technical debt rather than trying to just do a big bang work stoppage and pay it off.
Yeah.
Got it.
And as a CTO, you also do a lot of hiring. When you look at candidates who are just like getting their first job out of college, or they're getting like maybe they went through a non-traditional path and they're kind of knocking on the door wanting to get a seat on your rocket ship, what kind of qualities or what do you look for in those candidates, and how does someone make themselves stand out?
That's a great question. So personally, at least, I always try to, and I advise other entrepreneurs and folks I invest in and so on, I always try to hire for ability over experience typically, because that's something where it's better for a younger startup. You want someone who's hungry and has the ability and wants to prove themselves. In terms of what I'd look for on a CV, I would like to see that someone has rung the bell at least like once or recently. And yes, that could be, they went to MIT or Stanford. It could be that they worked at Google or Facebook. Those are kind of like name brands. But it could also be that they did a really great open source project, or they've got an amazing portfolio on their website and they're out in the middle of nowhere. Or they did well on like a programming competition or HackerRank or something like that. And so there are these avenues like HackerRank, like also HackerOne, which is different. HackerRank is like programming exams. HackerOne is like for security people, right? And there's folks who are coming out truly the middle of nowhere, like Mexico or India, Brazil, et cetera, and they're just crushing it, and they don't have any training. They're just Googled things, and I can tell they're really smart by what they've done there. So they have to have shown something that's world class, and then you hire them. But it doesn't necessarily have to be a traditional credential like a Stanford or MIT or Google or Facebook.
Got it. And speaking of like Googling things and learning, I think it'd be helpful to like talk a little bit about how you learn how to code. I know you recently tweeted something about like YouTube education and things like that. So how did you learn how to code?
Yeah, it's a good question. So I think my background is actually more in math than computer science per se. I did my BS, MS, and PhD in electrical engineering and MS in chemical engineering at Stanford, and that actually focused a lot more on statistical signal processing, computational statistics, complex analysis, partial differential equations, all that type of stuff, right? And I think that strong foundation in mathematics made computer science, I think, relatively easier. There's certainly, obviously, computer science is challenging and whatnot, but if you really understand math, CS, a lot of CS can be reduced to math. And so then given that mathematical foundation, I was able to basically self-teach a lot of computer science. You had to learn a lot of it for double E. When you're programming a circuit board or you're programming a robot or something like that, you're learning to program. Basically at Stanford, a double E would be able to program as well as anybody else other than a computer scientist, because you'd have like enough CS classes. But then there's like what you learn in school, and then what you actually learn when building something. And those are quite different. Like computer science and software engineering, it's the difference between, understanding how fast this algorithm is going to run in theory, and then actually implementing it in practice, deploying it on Amazon, writing clean code, writing multiplayer code that others can edit, maintainable code, and making money on it. Like now you start getting out of software engineering and into business. Those are actually less overlapping than you might think, and that stuff is almost entirely self-taught.